Okay, in this class we're going to talk through Chapter 4 in the trigonometry text. So Chapter 4, Preparation for Right-Angled Trigonometry, so we'll be starting on page 31 in the text. So I'll give you a minute to open that up so you're ready. Alright, so Chapter 4. So when we get to Chapter 5, we're finally going to get to the point where we can start discussing the trigonometry functions. But to get ready, we need to talk about a few more concepts first in Chapter 4. Alright, so starting on page 31. Okay, so the first concept we're going to talk about is the issue of similar triangles. So similar triangles are very important for right-angled trigonometry, and you might remember from previous geometry classes what the meaning of the word similar is. So it's a geometry term. So similar means that two geometric figures would have the same shape. They're not necessarily the same size, but they're the same shape. So on this page we have two different triangles, and this triangle has three vertices that are marked A, B, and C. This triangle has the endpoints or the vertices D, E, F. And there's a note here that just tells you that sometimes you'll see triangles named that way, where this triangle could be referred to as triangle ABC, this triangle could be referred to as triangle DEF. Okay, so similar triangles. So in order for these two triangles to be similar and have the same shape, then the internal angles have to be the same, because then that would force the two triangles to have the same shape. This triangle's larger, but they're still similar with the same shape. All right, now on to page 32. Now if you have two triangles that are similar, then they have what's called corresponding sides. So what do we mean by corresponding sides? So corresponding sides would be sides that appear in the same position in two different similar triangles. So we have two triangles, again the same triangles we saw on the previous page, and we know they're similar because they have the internal angles are the same. So what about corresponding sides? So here's an example. Let's take a look at side AB in triangle ABC. And we can name these straight line sides could be named using the endpoints. So this side has endpoints, or the vertex at each end is A and B. So this is side AB. So side AB in triangle ABC corresponds with side DE in triangle DEF. Now how do we know that they are actually corresponding sides? Well, you could identify them as being next to or opposite other features. So one way you could do it is you could look at triangle ABC, and you could say that side AB is opposite the 30-degree angle, and then in triangle DEF you could see that side DE is also opposite the 30-degree angle. So that's just confirmation that they are corresponding. In other words, those two sides appear in the same position in each of those triangles. And then there's another statement here that we'll check out. Side FE in triangle DEF corresponds with side CB in triangle ABC. Both of these sides are opposite the 60-degree angle. So we could indicate that this way. Side BC is opposite the 60-degree angle, and then also side FE is opposite the 60-degree angle. So they're both in the same position. Now, in terms of the naming of the sides, the order in which you list these is not important, at least for these kinds of lines. So side CB could be called side BC. It's the same side. FE could have been referred to as side EF. So for those kinds of lines, the order is not important. All right, so now let's go on. At the bottom of page 32, there's an exercise 4-1 referring to the figure at the bottom of the page. So go ahead and answer those questions. And you'll also notice that the assumption is we're just assuming that these two triangles are similar, and based on the given angles, that's true. Okay. All right, so the first question is, which side in triangle MNO corresponds with side PR in triangle PQR? Now, one thing we can do to help ourselves out here, just to be able to answer the question why, is, now this one's a little more difficult than the previous example because the triangles aren't displayed in the same orientation, so you're going to have to kind of imagine if they were both oriented the same way. So let's first start this out by determining what the interior angle is for the third angle that's not marked. So what is the value of that third interior angle? So you know that the angles in a triangle add up to 180, so you could calculate it as 180 minus the other two angles, minus the 46 degrees, and then also minus the 103 degrees. So that should be 31. So these two angles are 31 degrees. All right, so back to the first question. Which side in MNO, triangle MNO, corresponds with side PR? So PR is opposite the 31 degree angle. So over in this triangle, side, oops. So over in this triangle, oops. Side MO corresponds to PR because it's also opposite 31-degree angle. So your answer could be side MO or side OM. Once again, the order is not important. Question 2, which side in triangle PQR corresponds with side MN in MNO? So that would be side QR. The side MN is opposite the 103-degree angle, and side QR or RQ is opposite the 103-degree angle in that triangle. All right, let's go on to the next page, 33. And go ahead and, there are 2 exercises on page 33, 4-2 and 4-3. Go ahead and take a few minutes and do both of those. Okay, so let's talk about 4.2. All right, so which side in triangle RST corresponds with XY in triangle XYZ? It is side RS. In this case, you'll notice that RS is opposite the 43-degree angle, and the given side XY is also opposite the 43-degree angle. Now this is also an example where you could fill in the missing angle, and the missing angle should be 56 degrees. And then the second question is which side in XYZ triangle corresponds with side ST. So there's going to be XZ. Both of these sides are opposite the 81-degree angle. So in this kind of a exercise, you really didn't need to fill in the 56-degree angle, but there you go. Okay, the next exercise, 4-3. Now this one's only a little different in that you're asked the question, are these two triangles similar? And explain your answer. So these are right triangles, so you could start off by determining the value of the unknown angles. So this angle will be 58 degrees. This angle is 32 degrees. So yes, those two triangles are similar because both triangles have the same value for the interior angles. They're oriented a little differently, but they are similar. All right, then on with the questions. Which side in triangle TUV corresponds with side JK in triangle JKL? So JK is opposite the 32-degree angle, and in the other triangle, side UV is opposite the 32-degree angle. You also could answer that as VU or UV. And then which side in triangle JKL corresponds with side TU in this triangle? TU is opposite the 58-degree angle, so the correct answer over here would be side JL or LJ. All right, I'll let you do exercise 4-4 on your own. Let's skip down to exercise 4-5, bottom of page 34. This one is a little different. It asks the same question as the previous page. First off, are these two triangles similar? So first off, you have to figure out whether they're similar, meaning that they're the same shape. So first off, figure out the value of the angle that's not given to you yet in each of the triangles. So 63 degrees, and this other one, triangle, the unknown angle is 31 degrees. So if you step back and look at that, you'd have to determine that those triangles are not similar because the interior angles are not the same in both triangles. So because of that, we were really defining corresponding sides as applying to similar shapes, and they're not. So we're just going to cross out that question because that question doesn't apply, because the triangles are not similar. All right, on to, there's really two more concepts we're going to talk about. One is proportional sides, starting on page 34, and then after we talk through that, then the last topic is naming of the sides in a right triangle. All right, so let's get back to proportional sides. All right, so we're going to look at, so far we talked about corresponding sides, which sides appear in the same place. Now, taking that a step further, we can actually do a mathematical calculation using the sides, even if we don't have any angle information, if we knew the lengths of the sides, we could determine whether the angles were, or the triangles were similar or not, because the length of the sides must be proportional. So what we're going to do is we're going to, a proportion compares two different ratios. So let's, so it looks like these are the same triangles from earlier in the chapter. So we're going to look at ratios of sides. So one possible ratio is if you look at triangle ABC, the smaller one, we could express one ratio as the length of side AB compared to the length of side AC. And we can also look at the larger triangle and compare the ratio of side DE compared to the length of side DF. If these two triangles are in fact similar, then those two ratios will be equal to each other. These triangles are a different size, but because their shape is the same, the ratio of this side to this side should be the same as the ratio of this side to this side. And by the sides, we mean the length of the sides, the measurement, the measured length of the sides. So we can express, this is really a proportion. This is what we would call a proportion that compares two different ratios and sets them equal to each other. Now there are, for two similar triangles, there are other proportions too. We expressed one proportion, but there are other ones. There's all sorts of different ones. Here's another possible proportion, comparing length of BC to AC equals to the length of EF to DF. That proportion should be true as well. That ratio should be equal to that ratio if those two triangles are in fact similar. So let's go on to page 36 and let's do an example of that kind of a calculation. So what's the purpose of this calculation? Well, when you do this kind of a calculation, you're trying to determine from the given information, are these two triangles similar or not? Earlier in the chapter, we were determining that from the given angle information. We're not given any angle information here, we're just given the length of the sides. So what we're going to do is we're first going to determine the actual value of the ratio. So if these two triangles are similar, then you could say that the length of AC compared to BC should be equal to the length of DF compared to EF. So we could actually determine the value of that ratio and then look at them and see if they're the same. So for triangle ABC, AC is 6, BC is 7.8. Actually do the calculation. If you get your calculator out, it should be 0.769. And then if we look at this triangle, DEF, the length of DF is 9, EF is 11.7. If you do the calculation, it's 0.769. So you would conclude then that those triangles are in fact similar, because since the ratio of the sides is the same, then these triangles have the same shape. That's the only way that would work out. And as I said before, there are all sorts of other proportions you could use to prove the same thing. Length of AC to AB compared to DF to DE, or AB to BC compared to DE to EF. There's lots of different ones you could use. Now, in this case, though, since we're only given the length of two sides, to use these proportions, you'd first have to use the Pythagorean theorem to determine the length of the unknown sides, and then you could proceed to use these other proportions as well. All right, so let's go ahead and do a couple of examples. So go on to page 37 and go ahead and work those two examples for or exercise 4-6 and 4-7 to practice the calculation of the proportion. And what you're trying to determine is, from your calculation, are the two given triangles similar or not? All right, so let's talk through the first one, exercise 4-6. All right, so for each of these triangles, and they visually do look the same. They're presented to you in the same orientation. You're given lengths that appear to be corresponding. So first off, you'd set up a proportion. So here's what we can compare. We could compare side UW compared to side VW, and if they're similar, then that would be equal to side XY compared to side YZ. So then you can fill in the values that you're given 0.750 compared to 0.860 is, the question is that equal to 1.125 divided by 1.290? So what were your results? Are those two ratios equal to each other? I believe the answer is yes. This was approximately 0.872093. I think the calculator gave you a few more digits, and I believe those two ratios are equal to each other. So the answer to the question was yes. You could do this in several ways. Now, you also could have expressed your proportion like this: VW compared to UW equal to YZ compared to XY. These could be inverted as long as the sides were listed in the same order. The first one we did was side UW divided by the hypotenuse equals XY divided by the hypotenuse. You could invert both of them, you should have gotten you wouldn't have got the same numerical result, but you would have still had the same result in that the triangles are similar. All right, how about the next one? Same idea. Are the triangles similar? They were presented to you a little differently, not in the same orientation. So one way you could do this is set up a proportion LM compared to MN equal to XZ compared to YZ. That would be one way to do it. You also could do it again the other way. You could do MN compared to LM equal YZ compared to XZ. And I believe you'll find with that calculation that those two triangles are not similar. Let's see, this was once you insert the values, your proportion looks like this, and I believe those were not similar. Okay, let's go on to the next page, 38. Skip to exercise 4-9. Okay, so in this example, or in this exercise, excuse me, in this exercise, the little bit of a twist is that you're given some of the dimensions, but you're not given all the dimensions that you need. For instance, the two dimensions you're given in the smaller triangle are side GH and GI, but they correspond to JK and JL, and you're not given the value of JK. So you'll have to use the Pythagorean theorem to determine that side, or if you want to compare the two given sides in triangle JKL, then you'll have to use Pythagorean theorem to determine the value of side AH in the smaller triangle. So either way, you're going to have to use Pythagorean theorem. So I'll leave that for you to work on your own. And you can always check your answers in the back of the text. All right, so let's go on now to the last topic. Okay, this topic is, it's a naming topic, and we're going to need these names once we get into Chapter 5 in the trigonometry functions, because this is how we're going to refer to the sides of a triangle in using trigonometry. All right, so we're going to name the sides based on given interior or internal angle. The only exception to this is, as we discussed in a previous chapter, the hypotenuse is opposite the right angle. So we're always going to name the side opposite the right angle the hypotenuse. It doesn't matter which interior angle we're using for our calculation. So the hypotenuse is always the hypotenuse. However, now in this case, we're showing a right triangle that has two interior angles, and for this discussion, we're not giving them a value, we're just naming them. So we're using the Greek letter theta for this interior angle and the Greek letter beta for this interior angle. All right, so for these other sides, other than the hypotenuse, in this example, this side is the side that's opposite angle beta. And this side, the horizontal side, is the side opposite angle theta. So opposite is one of the naming conventions we're going to use. Another example is sometimes the sides are next to or adjacent. Adjacent would mean next to. So you could also call this side the side that's adjacent to or next to angle theta. And then similarly, the horizontal side is the side that's adjacent to angle beta. So each side can have two different names depending on which interior angle we're using for our trigonometry calculations. And again, we haven't got to the trigonometry functions yet. All right, so let's go ahead and take a look at this example at the bottom of the page. So we have two different triangles. Let's first focus on triangle DEF. We have two interior angles labeled. So in triangle DEF, which side is opposite angle theta? So you look at angle theta, the side opposite is side DF. The side opposite angle beta is side DE. The side adjacent to or next to angle theta is side DE. Now, we're not selecting this side for that answer because that's the hypotenuse. The hypotenuse is opposite the right angle, and it's always called the hypotenuse. And then the side adjacent to angle beta is side DF. Same idea with the other triangle ABC. The side opposite angle theta is side BC. The side opposite angle beta is AC. The side adjacent to angle theta is AC, and the side adjacent to angle beta is BC. All right, so now let's go on to the last page, page 40. So go ahead and take a minute and work through those two exercises. Okay, so here's some answers for the first one. You can check your answers versus these. And once again, if you call this side SR instead of RS, that's okay. If this side was you referred to as TS rather than ST, that's fine. The order is not important when the direction is not important. Okay? And then the last exercise at the bottom of the page is just asked a little bit differently. In this case, you're given the side and asked which angle is in play. So side LM is opposite which angle. So here are the answers for this one. So LM is opposite angle beta. LM is adjacent to angle theta. MO is opposite angle theta. And MO is adjacent to angle beta. All right. So that's all the content in Chapter 4. So here's where I'd like you to go now. There is, starting on the next page, which would be starting on page 41, there is a practice worksheet that covers all of chapters 2, 3, and 4. So this will be your homework to work through this worksheet, and this is in preparation for a test. We're going to test on chapters 2 through 4. I believe we'll probably do this on Tuesday so that we have time on Monday to answer your questions, any kind of questions you have. And the test will resemble this worksheet, and we will review this worksheet on Monday, and then with whatever remaining time we have on Monday, we'll start discussing Chapter 5, which is the trigonometry functions. All right. That's it for today.